Okay, so we are going to talk about database experiences designing Cassandra schema for Keystone. So we kind of designed a Cassandra database driver for Keystone for all the components of Keystone. So Keystone, so the primary motivation for us was we wanted to see if we can have a way to do a multi-region Keystone deployment. So yeah, that's how we started. We selected Cassandra for that. One way to achieve multi-region deployment of Keystone is having federation, but we wanted to have something more generic. That's why we kind of went with a distributed database. So yeah, so there are different ways to run multi-region deployment of Keystone. I've written down a few which we can do right now. MySQL master slave, you have, let's say you have two regions, you have master in one region, slave in another region. So you write data to the master and it automatically gets replicated to the slave in another region. The problem with this is you can't write to the slave. So basically all the writes will need to go to only the master. Another way is doing a multi-master Galera, again, which suffers from the problem that in multi-master Galera, since it's multi-master active-active configuration, you are going to have to write to both the region before you return an acknowledgement, and that means higher response times. Another solution which we used actually was just use a data store which has multi-region support built in, which is what we did with Cassandra. So in a multi-region deployment, what exactly do we need? These are some of the important points. Asynchronous replication. This is because we can't wait for data to be written to both the region and then return an acknowledgement, because if the regions are geographically separated quite apart, then it will result in higher latencies, which is not desirable always. Read write to all the regions so that yeah. The third thing is tenant isolation and fast API response times. Yeah, we chose Cassandra. We wrote Cassandra drivers for Keystone. Here is the 10,000 feet view of Cassandra. Cassandra is a replicated data store. So you can think of a deployment in two regions as we have a set of Cassandra nodes in one region and a set of Cassandra nodes in another region. And we kind of set up the cluster in such a way that the Keystone nodes will synchronously write to semi-synchronously write to the local data center, and the data will asynchronously be replicated to the remote data center as well. For example, in the test which we did, we had a five node in local and 5 node in remote, such kind of cluster with a replication count of 3 in the local data center and 3 in the remote. So data will be replicated thrice in the local region and thrice in the remote. So let's consider these two regions, region 1 and region 2. We'll have one Keystone running in region 1, talking to the Cassandra nodes in region 1. We'll have another Keystone running in region 2, talking to Cassandra nodes in region 2. Yeah, it has multi-region support out of the box. So basically, it's just the configuration variable which you have to set in while setting up Cassandra, that how many times you have to replicate, how to asynchronously replicate to the remote data center, and how many times. Just a small comparison, Cassandra has built-in support for horizontal scalability, fault tolerance, and geo-replication, which out of the box is not there with a relational database. So we kind of wrote the drivers. Some of the issues which we faced, one of them was in Keystone, there is this thing of that two projects cannot have the same name, and also two users cannot have the same name in one domain. So what this basically means is there are two unique constraints for a user and for a project. So we already have a unique user ID or a project ID associated with every user. So In distributed databases, you'll find that if you have to design the schema, you can have uniqueness constraint only on one column. So if you have another uniqueness constraint on any other column, then it kind of becomes slightly difficult to like handle such situation. So yeah, if you see, like we in OpenStack currently there is a limitation that two projects cannot have the same name. So how to deal with this situation? So the solution which we kind of had was, we'll just block the API where one can change the name of a user or a project inside a domain. So actually changing that field was the bigger problem. So changing a unique field which is not the primary key is a problem, and that's why we just block the API. Or what we can do is we can use a workaround, but again it's going to be racy. So we just thought we'll just disallow that API completely where we change the names. So yeah, that is one thing. A special note for the token table, we didn't implement a token driver for the token backend of Keystone. That is because it's nothing. UUID tokens are nothing but a queue for Cassandra, and it's a known anti-pattern for Cassandra. So that's why we just skipped the token backend and didn't implement a Cassandra driver for the same. And yeah, we are using memcached backend for UUID tokens. Yeah. So more about the test setup which we performed. We took 2 regions, 5 nodes in each region, replicating thrice in the local data center and thrice in the remote data center. So we total have 6 copies here of the same data, 1 Keystone node running in each region, and Cassandra's consistency level of local quorum with a fallback to quorum. What this means is it will first try to do a local quorum. It will try to write to 3 nodes, get acknowledgement from a quorum of out of 3, that is at least 2 nodes. It will try to get the acknowledgement back, and once it gets it back, it will return the saying that okay, your data has been written. But in case a local quorum fails, it will try to fall back to global quorum. That is, it will try to write to all the 6 nodes and see if it gets response back from 4 nodes out of 6 nodes, because 4 is the quorum value out of 6, and then it will return. So if you see, when it falls back, the response time are going to increase because it's going to do a quorum across the cluster. That is, it's sending a query globally to the remote data center, getting the response back, and only then saying that okay, your write has been succeeded. So we did this test setup on Amazon, and we chose local data center as Singapore and remote as North Virginia, the farthest 2 data centers you can get, to see like how much impact it will have. And here are the performance numbers. So get the information of a user in a MySQL setting, it was around 15 milliseconds. With Cassandra, we were getting around 23 milliseconds. Again, these are the end-to-end response times. That is, it also includes the response times which the Keystone server spends processing the request. If you see list all users, it's taking 14 milliseconds in MySQL, and in Cassandra it's taking around 48 milliseconds. So 2 things. One is it's an admin only API, so your user is not going to be affected by this much increase in the response time. The second thing is this behavior is happening because if you are listing all users for a distributed database, the request needs to go to all the nodes and then collect the response and send it back. So in MySQL, there is like only 1 node involved, and in a distributed database with multi-nodes, it's going to be all the nodes where the request is going to go, and that's why there is a higher latency. Yeah. So basically, this request is more like a select star without a where condition request. So in a cluster of 5 plus 5 Cassandra nodes, there is no effect on response times if 1 node goes down because of the way we have set up. If 1 node goes down, still the quorum will be satisfied. 2 nodes will always be up. The interesting thing is we wrote the retry policy which I talked about just a minute back. Even if 2 nodes go down, it will retry on the global quorum. The response rate will spike up, but you still won't see any failures. So even 2 nodes going down is kind of handled. And also you'll get a notification saying that the response times have increased and something has went wrong. So yeah, work in progress. We are looking into stable driver interfaces so that we can maintain Cassandra driver along with Mongo drivers out of tree with the in-tree Keystone's MySQL driver. Performance tuning and optimizing Cassandra queries. There are a couple of queries. There are a couple of places where what we are doing essentially is write after a read, which is not generally considered a good operation in distributed database. So just little changes there. And database migrations, we don't have a tool chain around that. So since we are using Cassandra and using Cassandra as ORM, and OpenStack currently has support for only migration toolchain for using SQL Alchemy. So that part is also yet to be done. Here are some of the links. You can find the code at GitHub. Written a small blog about how to set it up with DevStack if you want to test against it. It's a dev setup, so it's all in one node setup, and a link to the presentation. And that's all. Thank you.